You can buy a modern truck packed with radar, cameras, computers, and enough electronics to manage almost everything on the road. So why would a machine this advanced still avoid the same automatic transmission found in an ordinary car? Most people assume trucks are simply stuck with old technology, or that veteran drivers just refuse to give up shifting gears. But that misses the real story. Behind that gear selector is a hidden battle between efficiency, heat, weight, cost, and one clever piece of engineering most drivers never think about. Subscribe for more truck mysteries like this, because the real answer is not that trucks rejected automation. They chose a completely different way to achieve it. The automatic truck that isn't actually automatic. Look inside many modern highway trucks and the transmission seems completely automatic. There is no clutch pedal. The driver selects drive, presses the accelerator, and the truck decides when to change gears. From the cab, it can feel surprisingly similar to driving a large automatic car. But mechanically, something very different is happening underneath. Many of these trucks use an automated manual transmission, or AMT. At its core, the gearbox still resembles a traditional manual transmission, complete with mechanical gears and a clutch. The difference is that the driver's left leg and right hand have effectively been replaced by electronic actuators and a computer. Take Detroit's DT-12 as an example. Instead of using the torque converter found in most conventional passenger car automatics, it uses a clutch to connect the engine to the transmission. Sensors constantly watch engine speed, vehicle speed, load, throttle position, and other inputs. Then the transmission controller decides when to disengage the clutch, select another gear, and reconnect the drivetrain. So when someone says modern trucks have gone automatic, that is only partly true. The driver no longer has to shift manually, but the mechanical architecture underneath may still be much closer to an old-school manual gearbox than to the automatic transmission in a family SUV. And that distinction explains almost everything that comes next. Why garbage trucks? Love what highway trucks avoid. If traditional automatics were simply bad for heavy trucks, there would be an obvious problem with that argument. Some of the hardest working trucks on the road already use them. Garbage trucks are a perfect example. They may accelerate from a stop, move only a short distance, brake again, and repeat that cycle hundreds of times during a shift. Fire engines, city buses, concrete mixers, construction trucks, and other vocational vehicles can face similar conditions. In that environment, smooth, low-speed operation and uninterrupted power delivery are extremely valuable. A torque converter helps here. Unlike a conventional clutch, it can transfer power hydraulically while allowing some speed difference between the engine and transmission. That makes creeping forward easy and allows the vehicle to pull away smoothly without constantly engaging and disengaging a clutch. During repeated stop-and-go driving, that can be a major advantage. Now compare that with a long-haul tractor. Once it reaches highway speed, it may stay in the same gear for long stretches of road. It does not need to crawl forward every 30 seconds. It needs to move tens of thousands of pounds efficiently for hour after hour. That is the real dividing line. It is not simply about how heavy the truck is, it is about what the truck spends its day doing. The torque converter isn't too weak, it's the wrong tool. There's a common explanation for why highway trucks avoided traditional automatics for so long. Truck engines simply produce too much torque. It sounds convincing. Modern heavy-duty diesels can produce enormous twisting force, and a fully loaded tractor-trailer places far more stress on a drivetrain than an ordinary passenger car. But there is a problem with the explanation. Heavy-duty automatic transmissions can handle huge amounts of torque. Allison's 4000 series, for example, is designed for inputs around 3,200 Newton-meters in some configurations, while larger 6000 series units can handle even more. These transmissions operate in demanding applications including construction, mining, defense, and other severe-duty work. Strength alone is not what keeps them out of many highway tractors. The more interesting issue is efficiency. A torque converter transfers power through fluid, and during certain operating conditions there is a difference between the speed of the input and output sides. That slip is useful when pulling away because it allows smooth torque multiplication. But slip also means some energy is being turned into heat instead of motion. Modern automatics reduce that loss dramatically by using a lockup clutch. Once conditions are right, the converter can effectively be locked so power flows much more directly through the drivetrain. Manufacturers have spent decades improving these systems, and modern heavy-duty automatics are far more efficient than their ancestors. But long-haul trucking is an unforgiving efficiency game. A tiny disadvantage repeated over hundreds of thousands of miles can become meaningful money. So this question was never simply, can an automatic survive behind a truck engine? It can. The better question is whether a torque converter automatic is the best tool for a truck whose primary job is spending most of its life cruising down the highway. The industry automated the manual instead of replacing it. Truck manufacturers faced an unusual problem. Drivers wanted easier operation. Fleets wanted more consistent performance. But the industry already had a transmission design that was extremely good at the mechanical part of the job. The manual gearbox. Heavy truck manuals had been refined for decades. They were durable, relatively efficient, capable of handling massive loads, and familiar to mechanics everywhere. Throwing that entire architecture away just to eliminate the clutch pedal would have meant abandoning something that already worked remarkably well. So engineers took a different approach. They kept the gearbox. Then they automated the driver. Electric or pneumatic actuators took control of clutch engagement and gear selection. Electronic control units began communicating with the engine. Instead of a driver listening to engine speed and deciding when to shift, software could make that decision using data arriving several times every second. This is the trick behind the AMT. Mechanically, power still travels through a clutch and a gear set, much like it does in a manual transmission. There is no need to rely on a torque converter for normal power transfer. But from the driver's seat, much of the workload disappears. That combination became especially attractive as truck electronics became more sophisticated. The transmission could request a temporary reduction in engine torque before a shift. It could choose a gear based on vehicle weight. It could coordinate with the engine brake on a descent. Some systems can even use road gradient information to prepare for hills before the truck reaches them. In other words, engineers did not really ask, how do we make trucks use the same automatic transmission as cars? They asked a much smarter question. How do we keep the mechanical advantages of the manual while removing the human effort required to operate it? The AMT was the answer. The tiny fuel gap that becomes a fleet fortune. A 1% difference in fuel economy does not sound dramatic. For a normal car owner, it might barely be noticeable, but a long-haul truck can travel enormous distances every year while consuming thousands upon thousands of gallons of diesel. Multiply that across hundreds or thousands of trucks, and suddenly, 1% is no longer small. That is why transmission efficiency matters so much to fleets. Industry research has found that well-integrated AMTs can improve fuel economy compared with manually shifted trucks, with results often falling in roughly the 1 to 3% range depending on the application, drive, route, and equipment. The advantage is not necessarily that a computer can perform some magical shift that a skilled driver cannot. It is consistency. An excellent driver can shift a manual truck extremely efficiently. But fleets do not operate with one perfect driver on one perfect day. Drivers have different experience levels. They get tired, they encounter traffic, they hold gears slightly too long or downshift slightly too early. A computer does not have those variations. AMTs also make other efficiency strategies easier to use, particularly engine downspeeding. Instead of running the engine faster at highway speed, engineers can use faster axle ratios and operate the diesel at lower RPM, where modern engines can often work more efficiently. That places more responsibility on the transmission, because it must quickly select the correct gear when speed drops or a hill appears. This is where automation becomes more than a convenience feature. The transmission, engine, axle ratio, cruise control, and even road gradient data can work as one system. And when a tiny efficiency improvement is repeated mile after mile, truck after truck, year after year, that tiny number can become one of the biggest reasons a fleet chooses one drivetrain over another. So trucks never simply refused automatic transmissions. Engineers found something better suited to the job. Keep the strength and efficiency of a manual gearbox, then let computers handle the shifting. And that small distinction changed an entire industry. Click the next video to uncover another hidden piece of truck engineering. If you enjoyed this one, like, subscribe, and tell us in the comments which transmission you would choose. Thanks for watching, and I'll see you in the next video.